All right, we're going to talk about conditional probability. So conditional probability is the probability of an event given that another event has already occurred. So we're basing something off of another event. So the formula that you'll use is you'll do the probability of A given B, so that's how you read it. And then this is the formula. So what this formula means, and you'll also see the intersection, that's what that means here. So what this means is we're going to take where it overlaps, and then we're basically dividing out B. So you're just left with the probability of that. So let's go ahead and let's get started over here. So it says, given that a die lands on an even number, what is the probability that it's also divisible by 3? So for A, let's say it's all the options divisible by 3, so that would be 3 and 6 for your die. So that probability for A would just be 1/3. Now, for it to be even on your die, your sample set would be 2, 4, and 6. So that means it's 3 out of 6, which is 1/2. So this would be the probability for B. So what we're going to do is we're going to put it together in the formula. And it says here, the probability of A given B, and that's what I wrote here. So the probability for A is 1/3. The probability for B is 1/2. We're going to multiply those together, and then we're going to take out the part where they intersect. And so you're dividing it. So when you go ahead and you solve this, you're going to have 1/6 divided by 1/2. And remember, when you divide by a fraction, you need to flip it and you need to multiply by the reciprocal. So you're going to get 2/6, which simplifies to 1/3. So that's the probability. Now let's go ahead, let's look at this one. So for this example, a SPURT survey taken at a school shows 48% liked soccer, 66% liked basketball, and 38% liked hockey. Also, 30% liked soccer and basketball, 22% liked basketball and hockey, and 28% liked soccer and hockey. So if you notice, there's some overlap here. Finally, 12% liked all 3 sports. So find the probabilities for the students below. So let's go ahead and let's look at this first one. So it wants to know that Gina likes soccer if she likes basketball. So you're looking for the probability of soccer, and you're looking for the probability of basketball, and that is shown right here because it says both. Now we're going to divide out just those who liked basketball because we want to divide out that part that overlaps. So that's where we got the 66%, and you write it as a decimal, and we're dividing. So you're going to get 0.45 repeating. So remember, when you write that as a fraction, it should be 45 over 99, which equals 5/11. And then, so these two, either of these options would be a correct answer. All right, so now let's look at this next one. Chad likes basketball, so find the probability that Chad likes basketball if he also likes soccer. So let's find the probability of basketball and soccer. Now they just flip-flopped. They said basketball and soccer. The other one said soccer and basketball, but it's still the probability for both. But we're dividing out soccer. So the probability for both is 30%. The probability for just soccer is 48, and now we're going to divide those out. So you'll either get 0.625, or if you write that as a fraction, it's going to simplify to 5/8. So you're going to go ahead, you're going to try these two based off of the information up here. And remember, you're going to get the intersection and divide out the part that's overlapping. All right, so in this one, it says in the survey, 53% like cats, 42% like dogs, 10% like cats and dogs. Find the probability that a person likes dogs given that they like cats. So probability of dogs and cats, so this is the intersection. And then you're going to divide out the probability that they like cats. So that's the part where they repeat. So given they like both, that's 10%. And then the probability for just cats is 0.53. And divide those out, you'll get, and I rounded that, so it's 0.189 rounded. Or if you write it as a fraction, it would be 10 over 53. So again, you're going to go ahead, you're going to complete those, and then we're going to go ahead and start with this frequency table. All right, so the table shows the accounts of earned degrees for several colleges on the East Coast. The level, degree, and gender of the degree recipient were tracked. Row and column totals are included, so sometimes they're not, so make sure you're paying attention. All right, so this is bachelor's, master's, professional, doctorate, and then this is your total going this way. And then here you've got females going this way, males going this way, and this is the grand total of the column. Now this guy is the total of everybody that was surveyed or tracked. All right, so now it says, what is the probability a randomly chosen degree recipient is female? So it's saying of all people, so we're using that, and we want to know how many were female. Well, all the females, the grand total for female is 714 out of total amount of people, which is 1375. All right, so that's pretty easy from there. All right, you're going to go ahead and you're going to do this one. And then now let's use this letter C. We're going to still use the same table. What's the probability that a randomly chosen degree recipient is a woman given they received a master's degree? So of the master's degrees, how many were women? So what you're going to do is you're going to go to your master's degree and you're going to look down and you're going to use that total. So since we're of the master's degree, so that's where we got the 293, 128 were women. And then that's it. So you're going to go ahead and base off of this, you're going to complete that. And remember, this is given. So you're going to do the formulas from before where you have the intersection of A and B divided by probability of B. So go ahead, try those, and then we'll double check that. So just remember when you're doing this, conditional probability says something's already happened, and you're going to use this formula, and you're basically taking and dividing out any overlapping part.